Okay, so this is the second part of Chapter 2 for EE160. Mostly I'm going to help you out with the My Programming Lab because some things My Programming Lab asks you weren't really very well in the reading. So here I've opened up My Programming Lab and I'm in Chapter 2. And I'm making it big so you can see it, but I'm in Chapter 2, Introduction to Programming. The first concept that I'm going to look at is this section 2.4 on memory concepts. So if I look at this first topic area, it's on identifiers, and I'm going to click on the question. This one you should be able to answer already. So let's look at this question. What is the best identifier for a variable to represent the amount of money that you're paid monthly? So about identifiers, they should be as descriptive as possible. So this is a question about which one is the most descriptive. Not enough is maybe what you think about the amount of money that you should make every month. But if you were a programmer, talking about the amount of money you're paying somebody, monthly pay is probably the most descriptive identifier for this variable of how much money to be paid every month. Please notice that it's in camel casing, so the P is a capital letter. So specifically, I just talked about an identifier, so right here, this part on my PowerPoint slide. Identifiers are the names that are given to various program elements. They can be variables, symbolic constants, or functions. So with that in mind, as I'm looking at this slide, I want you to show me where all the identifiers are. I'm trying to get my pen back. Oh, my pen doesn't want to come back. Okay. Well, no matter. So the identifiers are the names that are given to various program elements, such as variables. So A and B is they are both identifiers. Factor is an identifier. C and D is an identifier. I don't see any other identifiers in here. In this case, they were names given to variables that we had declared and a constant called factor. We didn't declare any functions, but functions can also have an identifier. When you start writing your own functions, they'll have an identifier. I guess, so let's move on back to the Code Academy, the Code Lab. The next topic I'm going to talk about mostly this is terminology. So in section 2.5, I'm going to come back to exchanges because this one's a little bit more difficult. But in section 2.5, there's a whole section here about integer constants. And then it says parentheses literals. So let's look at what a literal is. So a literal is a fixed value in source code. So an example of a literal is 10.5 because factor is literally 10.5. Or another literal is 5.2. Or another literal here is 8.1. So these literals happen to be doubles of data type doubles versus integers, so they can be with a decimal point. But we can also have a string literal. So I have a string literal right here that says enter two integers. So a literal can also be a string. But it's something that's fixed, like enter two integers. It's something that's stored in memory. It's a string phrase, and that's literally the thing that's stored in the memory location. What next term? Oh, so let's look at what Code Academy, your Code Academy has for the exercises on literals. They actually threw me off a little bit at first, so that's why I decided to do this PowerPoint. So let's look at literals. And in this case, it says they're going to do integer constants, which are also literals. So write a literal representing the integer value of 0. 0. That is literally, it says the value is 0. It is a literal, and it is an integer. So That was correct. So you get the idea there. I think they're all pretty straightforward, these questions. I guess you have to know how many planets there are in the solar system for this question down here. There are, by the way, for the purposes of this lab, this exercise, there are 9 planets in the solar system. Let's not argue about Pluto. Let's see what's next of things that we have to worry about. Literables, variables. So a variable is the name given to a storage area that programs can manipulate. So A and B are variables. C and D are also variables. They've just happened to have been initialized. Originally, A and B are going to have 0 in memory or null because they haven't been given a value yet, and you've reserved that space. Now, also A and B is the identifier for that variable, so it's the name given to that variable. So C and D are variables. You could change the value of C and D if you want because I didn't declare them as a constant. So yes, that's the only variables I see here. So for also a point of confusion, I'm going to go ahead and mention it. It's going to come up many times in this course. What an argument is, it's the actual value a function is using, and it's also called the actual parameter. So a function, which we'll learn more about, always is inside of parentheses, like puts is a function, scanf is a function, printf is a function, getchar is a function, main is a function. Main happens to have no parameter in this case. So the argument is the actual value, not the variable that's sometimes a placeholder, but it's the actual value. So the string enter 2 integers is the actual parameter, also called an argument of this puts function in this instance. Let me go back and look at Code Academy now and see what we need to do for that. So the next section I'll talk about is the section on decision making, which was using our rational operators. So I want to say a little bit more about that. Here's a first example. Write an expression that evaluates to true if and only if the value of the integer variable x, so you have a variable x, is equal to 0. So the thing about this problem statement is don't read too much into it. They just want they don't say use an if statement or anything else. They say something that evaluates to true if the value equals 0. So giving you an idea, x before I submit that and see if it's right, I wrote x equals 0. This is a Boolean test. If this expression is evaluated and it's true, then actually the true will correspond to a 1, and I'll show you that in a moment. But it's a Boolean expression that's going to be evaluated as either true or false. It doesn't say anything to do with it. It doesn't say if this statement is true, do something else. It just says here is a test. It's a Boolean test that will evaluate to true if and only if x equals 0. So this is correct. So don't read too much into this section of the problem. Write an expression, this section of the My Programming Lab, not Code Academy. That's a website. Sorry, it's My Programming Lab. Don't read too much into My Programming Lab. So next one in this section is write an expression that evaluates to true if and only if the integer x is greater than the integer y. So again, it's an expression that's going to evaluate. But I'm not going to do this particular problem. We're going to go and look at an example instead. So more about if statements and that Boolean argument in particular. So I have a little piece of code right here. So you can see I've made a declaration for an int a and b and an int result. And what I'm telling what I want to tell you is that when you evaluate one of these expressions, one of these comparisons for that's a Boolean expression like a test, A equal B, what it gets evaluated, and if it's true, a 0 is returned, or if it's true, a 1 is returned, and if the value of this Boolean expression is false, a 0 is returned. And I have a piece of code to show you this example. So here you see I've declared an integer a and b and an integer called result. And then I ask the user to give me 2 integers. And then I do a test. If a equals b, so a equal b is my Boolean test that's going to evaluate to true or false. And if it evaluates to true, then you're going to do what's in the double or the brackets, because that's the body of my if statement. If it evaluates to false, you're going to skip these lines of code that are in the curly brackets, and you're going to go to the next section of the code. But if it evaluates to true, I'm claiming evaluating to true returns a 1 to your program, and I'm going to show you how. So what I did said, well, if A is identically equal to B, then I'm going to write the statement, well, glory be, to the console. But I'm also going to say, and this is the interesting expression, that result gets assigned the result of A equal B, or the result of this Boolean expression, or the result of doing this rational operator, equality operator that I just did. Equals is an equality operator. And so then I'm going to print what the value of result is. So you can see in my next expression, my printf, I'm going to tell you what the value of result is. So let's look at it. I compiled this little piece of code. I think I compiled this little piece of code. Let me check. There's my piece of code. Maybe not, because I see a save that hasn't been done. So let me compile it. Clear my screen. .cls. Come back up here where you can see it better. Yes. So that was the code to compile. And I'm going to run it. It says enter 2 integers. Okay, well, let's first make them not equal. 4, enter 5 equals. Well, nothing else happened in the program. I didn't execute the body of the if statement. So let's run it again. I'm going to enter 2 integers, and this time they'll be equal. Well, glory be, and as you can see, result got assigned to value 1. So indeed, if the Boolean expression evaluates to true, the result of that expression being evaluated is a 1. And if the result is a false, let's do A not equal to B. We'll compile it and show you. So if A is not equal to B, I'm going to print the result again. So let's try that one out. I'll tell you what the result is. Recompile it. Whoops. Rerun it. Enter. So 4, enter 5, enter. Well, glory be, they're not equal. Result equals 0. Okay, so there are some programming problems in the my programming lab. Put my programming lab back up here. Related to the true and false statements. Write a literal expression representing C's false value. So C meaning the program language. If something is false, what is the literal that corresponds to a false? It's a 0. That's all the program is asking for. It's just worded a little bit strange. Let's move on. Okay, so the next section I'll cover in my programming lab is the section on divisibility problems, because you need an example to so you can solve these. So it says assume that n has been declared and initialized as an int, so we know n is an int. Write an expression whose value equals the remainder of n divided by 17. So I said that that's the remainder operator. It's also called the modulus. So let me give an example here. So here's an example of a piece of code. I've declared two ints, a and b, and a result, which will be a result of the calculation. I ask a user to enter two integers. I enter them, I store them in a and b. And then this is the key line. Result equals a modulus b, or that remainder operator. Just to make that clear, I'm going to put a comment in here. This is the modulus operator. So for the purpose of that problem, I'm going to go ahead and use 17 as the remainder of something divided by 17. So let's see how that works. Whoops, that's not what I want. Let's see how that works. Let's see how our example works. Go back over here to where I compiled the program. Compile it. Run it. Enter two integers. So something divided by 17, what is the remainder of n divided by 17? Let's say 19 divided by 17. So my first integer is 19. My second integer is 17. And so it says the modulus, or the remainder, is 2. So let me, once again, I'll go over that syntax for you. The syntax right there. So I said, in this case, I was doing a divided by, the remainder of a divided by b. I could have just made b 17. But the remainder of a divided by b, the expression you write is a with that percent sign b, and that's called the modulus, or the remainder operator. So back here in my programming lab, down here, back here in my programming lab, n is declared as an int. Write an expression whose value equals the remainder of n divided by 17. So that would be n, remainder operator, 17. Submit. And yes, that's correct. So that's the remainder operator, also called the modulus operator. So the last problem area in my programming lab that I want to go over with is the one called exchanges. I thought, and it's in the memory concepts section. I thought this section was rather tricky for your, very first programs that you're writing, because usually I don't teach these exchanges till later in the program. But it does get you thinking about what's happening in memory. So I'm looking at this first problem here. See if I can make it show pretty well. It says given two int variables I and j, which have been declared and initialized, and two other int variables called iTemp and jTemp, which doesn't mean temperature, but usually in this case it would mean like temporary. So iTemporary and jTemporary, which have been declared. So you have four variables that are declared. Write some code that swaps the values in I and j by copying their values to the temporary locations, iTemp and jTemp, respectively, and then copying the temporary values back into j and I, respectively, like you want. Now, when you read this problem, it's 10048. It's a little wordy to get through, just thinking about what the program is asking you for. I kind of clipped that piece of text here. You probably can't read it, but it's kind of for my reference here. So I'm going to talk about the problem. So sometimes it's nice to write down the problem first and understand, and then you can write down the code. So it says you have I and j and variables ij, iTemp for temporary, and jTemp. And these are already variables that have been declared. So if you looked at my last year's videos, I talk about the process of solving a programming problem. And one of the processes is to do it on paper first and make sure that you understand what's happening on paper with real numbers before you ever even attempt to write the programming, the coding that goes behind it. So I do it first by an example. Let's say I have a specific case. Let's say that already in memory I has the value of 5 and j has the value of 7. So what do I want to do? I want these two values to get swapped ultimately, right? What I want is that I to now get 7 and j to get 5. So how am I going to swap those values? The problem gives you a hint. It says to use these temporary locations. So what you want to do, what you want the program to do, is you want to put the value of I into the temporary location I temp, and you want to put the value of j into the temporary location j temp, and then after that point your next line of code would be to say, okay, well now I, because I'm going to swap, I is going to get what's in j temp and j is going to get what's in I temp. So I temp, remember, had a 5 in it, and j temp had the 7 in it, and so the net result is I does in the end get the value that j previously had. So it does take you 4 lines of code to do this problem. So you're basically going to have to say that I temp gets what's in I temp gets assigned what was in I, j temp is going to get assigned what was in j, and then what are you going to do? You're going to do these two expressions. So I think there's 3 problems about exchanges. It's a nice thing to think about because, you know, how would you swap 2 values? There's an algorithm that we'll use later to make our code be better that has to use a swap. We'll actually make a swap be a function instead that does this operation for you. But it does make you think about what's happening in memory. Okay, so now about the homework. You're going to, from now on, do things from my programming lab every week. So my programming lab will check you, gives you, I think, unlimited tries to get the answer right. And then you're going to submit full programs to me, and you'll always submit your source code, which is your .c file, and your executable after you've compiled. So I'll always get 2 uploads for a complete program that I've asked you to write. So I'm going back to this slide that was in the previous YouTube, talking about the form of a program. So remember, it always starts with this header information, also called the preamble. Tells me who you are and what problem number that you're doing. And then I mentioned to not have too much white space, but you put white space in to make it readable, to make it more for it to be good. But you should not have ever 2 lines of white space in a row. There can only be 1 line of white space. You should have proper indents in your program. So once I'm within the body of a function, in this case it's the main function, my lines of code are indented. That makes it reasonable. I could write this program with no white space and no indents at all. I could run it all together in one big blurb of text, and it would compile just fine, but it would not be very readable. So when you submit the full programs to me, I have a grading rubric, and I'm going to upload it here in a moment on Lalima, so you will have it. But I will grade your program according to this sheet that I'm going to show you, and that's how your grade for a full program will be determined. Let me show you the sheet right now. Get rid of all my stuff I have open. Oh my gosh, I have so much open. Make it a little bit bigger. Yeah, let's just zoom. What happens if I go to 200? Close enough. I think I could see that. That looks pretty good. So this is a Word document that I fill out, and I return it to you when I grade your program, and you'll have a grade in it. So this is a program evaluation sheet. You need to put your name and date on it. You need, you need to submit maybe you can see the sheet, but I will submit the sheet for you when I grade your program. Yes, that's probably what I'll do. Okay, so let's look at how each program is graded. There's a general section, like does the program actually function like it's supposed to? Is the output accurate? Like if the output should be 52.897, did your program output an integer of 53? So that's like an example of an output being accurate. Does it compile and run? That I test that by you sent me a compiled version of it. Every now and then I'll check your source code and compile it myself and check it. Notice that's worth 5 of your points. Logic is efficient. That means no repeated code when functions and loops can be used. Well, we haven't learned functions and loops yet, so you can repeat your code. That's okay. And then there's a bunch of style components, which is the other 50% of the grade. That you have your comments, where comments are supposed to be the preamble, that's the top of the program, and for each function that you defined, which you're not defining functions yet. Constants should be all uppercase. They should have a meaningful name. Use proper indents and spacing. That means no excessive spacing. So the red hashes here are where I put comments about when I'm grading your program. I give you feedback. When we start naming functions, the functions should have a meaningful name, and it should begin with a verb, because functions do something. Like if your function is calculate average, name your function calculate average. Make it meaningful. Don't name your function CA or AV or something like that. It has to be something meaningful. Long names are okay. We'll get to labels at some point, but they need to be short and meaningful in lowercase. Your variable names, I said it should be camel casing, and it should be also a name. If I have a variable for my temperature, make it temperature. If I have more than one temperature, temperature inside, temperature outside, then call it temperature inside, temperature outside. And do camel casing. So remember, camel casing is the first letter is lowercase, the middle letters, this is an example of camel casing right there. And it should be a noun. There is an exception when we start doing loops, the loop iterators, which is how many times you're going through the loop, like for I equals 1 to 10. Iterators, I, J, K, X, Y, Z, those are okay. They don't have to be called iterators. And lastly, please name your programs that you submit with this convention. I don't care about the first one because it was not consistent, but name it, last name, whatever the chapter number is, and whatever the problem is. So for example, I'm going to assign you this week a programming problem at the end of chapter 2. It's 216. Problem 216. So if I were submitting my own homework right now, it would be named Pervinus _2_16 and then .c at the end for the source code. And the executable, please name the executable the same. It just makes it easier. I have to download every single one of your programs, and they need to have names that I can keep track of, so I know whose program is who, and so you don't overwrite somebody else's program. So you need to name your program with this convention. So anyway, that sheet will be on Lalima, so you can look at it and reference it. Please go to it and check your program before you submit it to me, so that you're sure that you've met all of these criteria for scoring your program. Because you'll get this evaluation sheet back filled out for the program that you submitted to me. Okay, thank you. Bye for now.